Aloha and welcome. In this lesson, we're going to be talking about binary data. Binary data is probably the most difficult to understand section that we have in this chapter, and probably one of the most difficult sections in this entire course. And the reason for it is binary data is a little bit different from what we've been dealing with up until now, and they're introducing concepts in this section that they really don't go into detail about, and they're not really doing a good job of explaining it either. So they do have a couple of addendums at the bottom. They have a couple of references that they want you to check out. One of them is the bytes documentation inside the python.org documentation itself. They talk about concepts like Little Indian and Big Indian without really getting into the explanation of it. So that's another thing that you can dig into if you want, but it really just has to do with the type of character encoding. And I don't know if that's really going to do anything but confuse you here. It's really not relevant to a lot of things, I don't think. So I don't get hung up on it. If you don't understand it, don't worry about it so much. Really, what's going to be important is the concepts of creating binary data, manipulating it, and writing it out, reading and writing it from files. So I'm going to get into a little bit of that here, but just keep in mind that this is a rather difficult section, but I wouldn't really worry about it too much. In all of my years writing, most of the things I do with files is going to be on clear text files. It's going to be on readable files, not binary data, because binary data is more specific to different types of programs. Like, well, let's just jump into the lesson. But essentially, binary data, an explanation of it is data can be stored as a sequence of bytes that are not encoded in readable format. They're used to capture image data, like videos, PDF files, things like that. Those are stored in a binary format as opposed to like ASCII and UTF-8 based files that you can just read with a text editor. So in order to work with these, we use a bytes object, and the bytes object can represent a sequence of single byte characters such as binary data that you can read from that file. One thing to keep in mind is byte objects, they're immutable, so you can't change them after you create them. So without further ado, let's jump into a screen share here. As always, we're going to bring up VS Code, and hold on just a second here. So looking in here, we're going to create some binary data using the bytes command here. We're going to create a string that's going to be ASCII encoded. So when we run, actually, let's go ahead and comment that out. So when we create this, you're going to see that it creates this thing. It's a byte literal. So it's going to create this string that starts with a B, and that's to denote that this is a string of single byte characters. So we can also create a bytes object by just specifying a number as the argument. And what that's going to do is it's going to create a bytes literal that has 100 zeros in it in hexadecimal format, in raw format there. So you see here, it's got the literal, and then it's got the \x, 000000. So it's putting in all zeros here. So then for our last example, we're going to be creating a bytes object using a list of 3 different numbers. And when we do that, you can see that we get this bytes literal with the 3 different values in there for 12, 15, and 20. So that's how we can create these things. This is known as, it creates a bytes object. We can also do this kind of manually. So we can go over here and we can create a byte literal like we came up with down there. And then just to show you what the type of said thing would be, when we run this, we get, this is a bytes literal. So we're specifying it with the B in front of the string. And then we're asking for the type of that same thing. And we get, this is a bytes literal. And we also are told that it's of class bytes. So that's kind of what we expected. We can also print out these things. So if you wanted to do a printout of it, you could say, print this, and then you could put in the raw byte values there as well, and that should come out to the same thing. So this is one area that they really don't go into explaining the different binary, the raw binary values there, and I just think they do a poor job of explaining that in general. So that's one of the weak points of this, but honestly, you don't need to delve into that too much. We're going to be kind of sidestepping that and going into other things now, because we want to talk about accessing files in binary mode. And the way that you do that, if you remember from the past when we opened up a file for processing, we open it up with a mode, and that mode was R, W, or A in general. And if you want to, and by default, it opens up for text editing. But if you wanted to open it up for modifying a bytes, a file containing bytes, you would append a B to it. So instead of having like a R, we'd have an RB for reading binary. And then we'd have a WB for writing binary. So I'll give you an example of that. So we're going to go with our right here. We can open up a file, and I haven't actually created it yet, but we're gonna go ahead and put it into the directory that I'm in, and we're gonna open it with write for bytes, and then I'm gonna create a string literal here, and I'm gonna write that to the I'm gonna write that to the file. So after we do that, we're going to close it. So if we run this, well, actually, let's go ahead and comment out this stuff up above and comment that out. Then we're going to run it, and nothing happens because we've done nothing exciting. But if I was to try to open up the file that we just created, I would hear, there it is, binaryfile.bin. We open it up, it says, this is my contents. So that's nice to see. So then we go back over to our examples, and what we want to do next is open that file up for reading. And after we read that in, we want to go ahead and we want to read that in and then print out the value that we get there. So we're going to run this. So we're opening it, we're writing the file contents, we're closing it, and we're opening it up again, and then we're going to read it and print it out. So when we do that, it comes out with B, this is my file contents. So it's giving us a bytes string there, and that's exactly what we expect. And if we were to go over here and let's say type of this and see how that goes and see what we get class bytes. So the data that we're getting back from that is class bytes as we expected. So one thing to keep in mind is on Windows, the \n in binary mode doesn't map to \r\n. So when you're using text mode, Python's translating line endings like that for compatibility issues. So it's the same whether you're using Windows or Mac or Linux. So in binary mode, it doesn't do this because it would corrupt the binary data. So let's see. So just to recap there, when we do, we can do a read like over here, and this read is going to return the byte object as we saw when we print out the type of it. And then when we do a write, the write is also expecting a bytes object, and we have a bytes literal here. So that is, essentially the bytes object. So we're sending the literal, or we're sending a bytes object to it essentially. So that's the main gist of interacting with files. Some other points to keep in mind when we're printing the bytes. Hold on. Actually, they had an example, and I wanted to talk about that example. They're reading a bitmap file, and a bitmap file is it's an image file with a .bmp, And they opened it up, and when they did that, they did a printout of what they read in. And what you could see in that read was that it would give you, you could see a little bit, and then it got into all these, backslashing, escaped characters. So the part that was readable in the beginning, it had the part that's readable is essentially the byte header. It's got a 14 byte header for BMP file. So the 2 bytes indicated the type, which was BM, I believe, and then it had a 4 bytes that gave you the size information, and then it gave you the information on where the RGB values were for each pixel. So that was kind of interesting. Opening up a BMP file and then editing it. It's kind of a neat thing to do if you know how to do that kind of thing. But one thing they really went over lightly, I thought, was using struct. And struct is one of those functions that you can use. You have to import struct. So you do it kind of like this. You do an import struct. Actually, hold on. Let me go down here. So when we can do when we're going to make something like a set of or a string of binary data here, what we can do is we can use the struct the module. So what we're going to do here is we're going to use struct to build a byte sequence that we're going to pack and unpack. And what we're going to do with the pack, I'll show you an example of pack in just a second. The first thing we have to do is import struct. Okay, so struct is the standard module. It's in the standard library, and you have access to that just by doing an import of struct. And then we're going to do a little print here. And this print, the first line here, we're just saying result of packing 5 and 256 and 4. And we're saying end is the space so that we don't actually do a new line. So then we have print struct packed. And this is where another area where they don't really get into too big detail, but this greater than sign here is basically telling about the endianness, whether or not it's going to be little endian or big endian. This is going to be big endian, and if it was a less than sign, it would be little endian. Don't worry about that. If you want to learn more about that, you can look it up. It goes back to, I think, the book on the Lilliputians, and it's or Gulliver's Travels, but they use an expression from there to talk about this, and it just has to do with the way it saves the data that you're dealing with. It has to do with the significance, whether it's going to be doing the higher or lower. But you just have to worry about making sure that when you're if you're going to be writing it out or constructing it with the greater sign or the big endian, then you also need to be reading it with the big endian, or else it's going to reverse the order of the byte sequence. So you don't want to do that. Just be consistent across your packing and unpacking is essentially the story here. So that's whether it's big endian or little endian, the greater than or less than. Then you've got your characters that specify how many bytes these different things are. So we're saying that we're using H, and H specifies a double byte sequence. So you've got 4 different ones. You've got H, you've got B, you've got L, and you've got S. So the H represents, I think it's a double byte integer. B is I think the B is a single single byte integer, and L is a 4 byte integer, and then S is an ASCII string. So what we're going to do here is we're going to, let's go ahead up here and comment all this out. And over here, we're going to say, let's just go ahead and run this right here. So what we see is result of packing 5 and 256 and 4. We get this bytes literal, and you can see that it's got the X00, x05, 01, 00, 0004. So we've got 1, 2, 1, 2, 1, 2. So we're saying that with H, it's a double byte, right? So you've got the first byte, the second byte, first byte, second byte, first byte, and second byte for each of these numbers. So we can also unpack things, and unpacking gives you a tuple. So if we were to take, let's say we just take the same thing we just had, and hold on just a second, I'm going to copy down here to make this a more interesting lesson. So we're going to go ahead and take what we just had, and we should get the reverse. Actually, note also this should be 3 different ones. So we've got 3 different characters here, and we're making sure that it's big endian there. So when we run this, we get back a tuple that has 5, 256, and 4, which are the values that we put into it originally. So we know by reversing it that, and it came out the same, that the initial one worked as well. So that is packing and unpacking. And these are the processes by which you can construct those sequences of bytes. So that's it for this lesson. Again, I apologize for it being a rather, I wouldn't say esoteric, but really a lightly explained section in the chapter. And I was kind of disappointed that they really don't go into more detail, or at least use this a little bit more to fully flesh out the ideas, because yeah, when you're dealing with binary, it's a lot different than dealing with text, which is, you know, easily read and everything else. They don't give you any instruction on, you know, hexadecimal number system or anything like that. They just kind of expect you to understand that, and I think that's a little bit unfair here. So if you have questions about this, feel free to reach out to me, send me an email, and I'll try to respond as soon as possible, because this is definitely one of those harder sections. But to be honest, I have not really done much in the way of, well, only on 1 or 2 occasions have I had to read or write binary data. And yeah, the tools are there. You can delve into it if you like, but this isn't necessarily something you're going to be doing a lot, you know, of processing with. Most of my file access has been probably 99.9% of all my file access has been strictly through you know, clear text, you know, text files and things like that, configuration files and things. So anyway, dig in. If you have any questions, feel free to send me an email, and I'd be happy to help you out. Take care, and I'll see you in the next lesson. Aloha.